think of relationship? Okay? What do you think of? No, what, okay, what is a relationship? When you have, okay, two things that go together, what do we have? We have a couple, it's a pair, a match. I like to think of it as a bond. Okay? Listen. Guys, I like to think of a relationship as a bond between two people. Now, me and my best friend have a relationship. We have a bond together. Okay? Now, X and Y have a bond together. Right? Because without X, Y can't function. And without Y, X can't function. X and Y, the point is a relation. They have a relationship, so we say that they're a relation. Okay? Does everybody get that so far? Alright, now, a function is a special type of relation. Okay? Now, just like, and I'm going to get more into the whole relationship aspect, use that in a little bit. But on your paper, you see the top A through D, okay? And then you have the bottom A through D on your first page, okay? Now, the top A through D are called functions. These are functions. What that means is that they have a special relationship, okay? But the bottom A through D, they're not considered functions. They don't have a special relationship. They don't have a special relation. Okay, so what I want you and your partner to do, I want you to come, I'll give you about 5 minutes because this is a little difficult. See what is different from the top 4 functions and the bottom 4 not functions. What do you see that's different? Okay, so you and your partner discuss. What looks different? Now, compare apples to apples. Okay, meaning, compare B at the top with B at the bottom. Don't compare B at the top with C at the bottom. Compare apples to apples here. So look at B at the top, look at B at the bottom. What can you conclude? What can you see? Look at D at the top, look at D at the bottom. So you and your partner right now, y'all talk about what you possibly think. What makes a function a function? Okay, so talk with your partner. What do y'all see? Okay, let me tell you this. The type of number does not matter. If it's negative, if it's positive, if it's a decimal, if it's a fraction. That doesn't matter. That has nothing to do with what makes it a special relation. Well, look at all of them. Compare A with A, B with B, C with C. What makes the top 4 special and the bottom 4 not special? Write it down on your paper. There's a spot at the bottom to write it down.
Does it do like, if there's like a difference, does it mean like it has to do with numbers, like, you know, numbers?
No, it doesn't have to do with an operation, no.
No, like, no, with numbers, like.
Yeah, it has to do with numbers. It does have to deal with numbers. I know, it's not going to jump out after you. Compare B at the top with B at the bottom. Compare D at the top with D at the bottom. Let me tell you this. It's easier to see it with B and D. Comparing the B's and D's than looking at the A and C. The top 4 is a function. The bottom 4 is not a function. So what makes the top 4 a special relation?
You're making my head hurt.
Oh, good.
What you said again? I have to
Compare this B with this B. This is a function. This one is not a function. So what can you conclude? This one is a function. This one is not a function. Look at the two and see if you can see a difference.
minus 3 plus 2 minus 2 minus 1
not your partner. That's your partner. We should be talking about what makes A through D a function and the bottom A through D not functional. Guys, look. Try and break this apart. What makes the top really special and the bottom not so special? The bottom doesn't have a pattern at all. Okay, it's not necessarily a pattern. Not necessarily a pattern. Well, there's no. I say there's no pattern. It's not like the pattern y'all thinking of. This stuff is not hard. You shutting down without even thinking about it. Think. Think. No. Let's talk about this. Since I gave you the hint that B and D was easier to see, okay? So let's look at B at the top, because B at the top is a function, and B at the bottom, okay? Which is not a function. Now B at the top, what's my X values for B at the top?
7, 4,
Okay. What's my X's at B at the bottom?
7, 4, 5, 5.
Okay. Let's name something different about that, Christian.
They're not all different.
Okay. Christian says the B at the bottom, they're not all different numbers. Okay? Not all the X's are different. All right? Let's see if that holds true for D. D at the top, what's my X's?
55, 60, 60.
Okay, what's my X's at the bottom?
14, 15, 16, 16.
Okay, does Christian's statement hold true for this one?
Yep.
Yes, right? Not all my X's are different at the bottom. That might be a pattern. Okay, let's look at A. Now A is the third one that's easiest to tell. What's my X's in A?
1, 2, 4, 7.
What about A at the bottom?
4, 7, 4, 2.
Ah, am I starting to see it now?
No.
Yes,
I see
they,
what he's saying.
Okay.
the functions.
Okay.
I don't see it.
All right, let's talk about relationships now. Okay? I know this will clear up everything. All right. So we said a relationship is a special bond, okay, between two people. Okay? Well, if I have a special relationship, let's just say our standard relationship a boy, girl. I'm just using that. I know there's other. I'm just going to say boy, girl for this class. Okay? Guys, stop. Okay? If one boy likes one girl, is that a special relationship?
No. Yes.
Okay? That's a question. Okay. What if that one boy likes 10 girls? Is that a special relationship? Okay. So let's think about that. Okay, let's think about it. Guys. So the special relationship was if I had one boy, I had one girl. So my special relation is if I have one X, I have one Y. Whereas the not so special relationship, I had one X and multiple Y's. Okay? So, hold on. Let's take a look at B at the top. Because a function is a special relation. Alright? Now, the B at the top, does every X have one Y?
No.
Yes. Okay? Listen. Y'all are not listening. Does every X for B at the top have one Y? Yes. If I said X is 7, could you tell me who it likes? 4. If I said X is negative 3, could you tell me who it likes? Okay. Look at B at the bottom. If I said X is 5, could you tell me who it likes? You could tell me who it likes.
But it's not only one version.
Right, he likes 3 and 4. So is he special? No, that's not a special relation. So that is not a function. Y'all starting to understand it? Okay. So, let's look at A at the bottom. Now, all the bottom ones are not functions. And we're going to go through each one and say why. Okay? So, raise your hand and tell me why A at the bottom, Hannah, is not a function.
4 has 5, 3, and
Good. Well, 4. Okay, the X value 4 likes 2 people. Yes, a 5 and a 3. So that's not special, so it's not a function. Okay? B we already went over. C. Hold on 1 second. Raise your hand and tell me why C. Somebody other than Hannah. And you'll hear that on your... Somebody other than Hannah. Okay, Shawnette, try.
is it like 0, like -2, and
Beautiful. Okay, she said C because 0, my X value, likes -2 and 1. So that's not special. Okay? Do you see how the arrow from 0 goes in 2 different spots? Now, what's your question, Marissa?
But then why 4 likes -2 and 2?
You're right. Okay, so we're going to get into that definition in a second. So what she said, well, let's look at, listen. She said, let's look at the reverse way. Well, why the Y1 has 0 and 2? Okay, I'm going to talk about that in a second. Okay, so hold that thought. D, Christian, tell me why D is not true.
Okay, there's 16 like 3 points over 2 points.
Good. 16 has 2 different people it likes, so not a function. Okay, so let's write the definition of a function, and then we'll come back to C. Okay? Yes.
Like, what if
Hold on 1 second.
like a number and another number like the same number?
And that's what we're going to talk about. I'm going to talk about that. Okay? All right. So, on the next page at the top. So, flip over your page at the top. I'm going to give you the actual definition of a function. Oh, that was for y'all to jot down. Okay? But at the top, okay? Now, I'm going to give you the actual definition. Of course, I cannot say when one boy likes only one girl. That's not the actual definition in math, okay? That's an example that I use to help you all understand. All right, so a function is a relation in which, write this down, every input has exactly one output. Every input has exactly one output. So, every input, no, has exactly one output. Okay? No, the C is the bottom. But yes, the C is the top one also. I'm going to talk about that. Okay? Alright, so the definition, the mathematical definition says a function is a relation in which every input has exactly one output. Now, input and output, those are just fancy words for what? X and Y, okay? Now, so I'm just going to put in parentheses X and Y. Now, they could be W and Z, okay? It's just whatever goes in and whatever comes out. You know, I could put in a frog and get out a banana. That's my input, that's my output, okay? But for for algebra, we mainly see X's and Y's. All right, let's flip over to the question Marissa asked earlier, okay? Let's look at C at the top. Now, C at the top is a function because it is a special relation because there is one input for every output. But there's something odd about C. What is odd? Okay, -2, and this answers your question. C at the top. Okay, so -2 and 2, like 4. Okay, now, my X's are my input, correct? Okay, so if I said I have an input of 4, could you tell me the output? 16 would be the output, okay? Then I would say my input is 6. What would you tell me? 36. Then I would say my input is 2. What would you tell me? 4. Is that only one output? Yes, that's still only one output. Now if I said -2. 4. Is that only one output? Yes. It's okay for the Y to be going to 2 X's, but it's not okay for the X to go to 2 Y's. Okay? Right. Okay, so let's look at C at the bottom. Okay, let's look at C at the bottom. Okay? Now, we said earlier that it's not a function because 0, if I say my input is 0, what's the 2 outputs? -2 and 1. Since it can't decide which one it likes, it's not a function because it's not a special. Okay? But notice 2 and 0 both go to 1. That's okay if they both go to the same number as long as one input has only one output. Does everybody understand that? Okay? So what if I had this? What if this was my data, my table? 1, 2, 3, 4, 5. So these were my X's and these were my Y's. And I asked the question, is this a function?
Yes.
I think it's a yeah.
Okay?
Yeah.
For every input, is there only one output? Yes. It's okay if it's the same output, but do I have any X repeating itself? No. Okay, so this would actually be a function. As odd as it looks, it would actually be a function.
Really?
Yes.
What if you have like 2 and -2 and they move equal?
That's a function because they both.
I know.
Okay. All right, so let's continue. All right, let's go, okay, so on the second page it says, since a graph is a set of ordered pairs, and an ordered pair is just a relationship between two things, then graphs also have relationships, okay? So a graph could be a function or not a function, all right? So the top 4 are in fact functions, and then that 2 at the bottom and the 2 on the next page are not functions, okay? And I'm going to give you the quick and easy way to tell if a graph is a function. So on page 52,
If they make a line.
Where it says, how can you determine if the graph of a relation is a function? Right? Vertical line test. Okay, so where it says on page 52, how can you determine if the graph of a relation is a function? Right, vertical line test. I'm going to give it to you, but I just wanted to answer the question. Okay? Alright, so what in fact is a vertical line test? You're going to write this down. Here's the definition. So, draw vertical lines. Hence, vertical line test. If vertical line, yes. If vertical line crosses the graph at more than 1 point, it is blank a function. It is not a function. Okay? So you're going to draw vertical lines, and if a vertical line crosses the graph at more than 1 point, then it is not a function. Now, anywhere on the graph. Okay? Now, if it crosses at more than 1 point, what does that mean? It's not a function, so what does that mean? It has what? More than one output, right? If it crosses at more than one spot, that means it has more than one output. Alright, so let's go back. Well, let's look at the top two. The graphs right above that. See the circle graph? Draw vertical lines on that for me. On the circle graph, the top left graph, draw some vertical lines.
Alright, how many?
You can draw to your heart's content if you want.
Do they have to be perfect and stuff?
I see a graph that has a circle on it. Okay? Alright. Draw some lines.
I'll choose the line.
Okay. Now, on any one of those lines, does that line cross that graph at more than 2 points? At more than 1 point, I should say. It should, right? Okay. This is what I want to see on your paper. Let's see. Here's my circle. Okay? I'm going to draw my random vertical lines in purple. No. Then I'm going to pick one line to look at. Oh, here's one of my lines.
No, it's not.
Ah, does that cross at more than 1 point? Yes, it does. So it is a function? No, that one's not a function because it crosses more than 1 point. All right, let's look at the next one. Okay, this is actually called a parabola, and you don't learn about those until Algebra 2. We're just going to look at the graph, okay? If I drew a vertical line anywheres on this parabola, would it hit in more than one spot? Yes, so is it a function? No. A function can only hit once, okay? So, for example, I draw my line up, it hits in 2 spots, so this one's not a function. Yes. Yes. Yes.
So like on that one, you couldn't like draw it all the way over here.
You want to draw it on the graph. You have to draw it on the graph.
But the graph is like what you already drew.
Yes. Yes. All right.
If there's like one dot on one line, that's called a pair, right?
One dot on one line.
Like, if there's like only one dot like on the line.
That's a function. Then that is a function.
Okay, there's 2 dots, that means that's not a function.
2 or more, not a function. Okay? All right. Let's go back to the previous page.
But Miss Lamb,
Yes.
look at this, right? Say I drew a line, like, right?
No, you want to draw it on the graph.
What,
The circle is the graph.
yeah, but like, what if they go in after circle? What if that's like polka dots all over the place?
Okay, we're going to look at that. Okay?
I'm watching.
All right. So, the previous page where they have 6 graphs on it. Okay, y'all see that?
Yeah.
This page. Page 51. Let's look at the top right one. Draw me a vertical line on there. The top right graph. Draw a vertical line. It's below the x-axis. It's the darker line going horizontal. Page 51. The top right.
So we draw like a vertical line.
Okay. All right. Listen, the top right graph. This is what it kind of looks like. Okay? Draw a vertical line on there. Anywhere.
It's a function.
Is it a function?
Yes, it's a function.
Why?
Because it only hits at one point.
Because it only is going to hit it one time. Any vertical line you draw is only going to hit it once. No matter how many times you draw the vertical line, I'm only going to hit it. My vertical line is only going to hit that red line one time.
I get it now.
Okay? Go down to the bottom right one. Okay? Now the bottom right one, picking the line for you to know which line I'm talking about. So I can only draw one vertical line on that graph, and that's the one already there. How many times is the vertical line I draw going to hit that line? Infinitely many, right? 10. Okay? As much as the line goes. So,
A badillion.
the bottom right one, is it a function?
Yes. No. Wait, no.
No, it's not a function. The bottom right one is not a function. Guys, there's only one place I can draw a vertical line on the bottom right one. And that's where the vertical line already exists.
Wait, why can you only do one? Because that's all.
Because that's the graph. The graph doesn't extend further than that. Okay? Jonette, pick your head up off your desk. Alright. Let's look at the second graph on the left in the middle. When you draw a vertical line for the second graph in the middle on the left, that's a parabola that goes, yes, that's a U shape. It is a function. Why? Because it only touches it once. Alright, so we understanding the vertical line test?
Yes, but wait. I don't understand this one.
Okay. Alright, let's look at the bottom left one. Now,
Oh, I didn't see that on the wall. Maybe you got it wrong.
I know. Okay, the bottom left one, guys, there's points. There's not actually a line drawn, but there are points. And it's kind of hard to see where the points are. Okay, so here's my graph that I duplicated for the bottom left one. Now, draw vertical lines. Will you hit more than one point?
Yes.
Yes, you will. Right? If I drew this pink line, that vertical line, I will hit more than one point. So it is is it a function? No, that's why it's not a function.
What about if you drew the line on the third dot from the top?
Okay, the vertical line test is if any vertical line I draw crosses more than one point, then it's not a function. I'm not just going to say, oh, let me draw it here so it only hits one point. No. Yes. I'm looking at the graph saying, if I can draw a vertical line anywhere and it hits more than one point, then it's not a function. Uh-huh. Because the only line I could draw... Okay, so here's the graph, right? If I drew a vertical line, the only one I could draw would be that one. And it would hit the entire line. So it's hitting more than one point, so it's not a function. There's a vertical line on that vertical line. Okay. All right. Let's look at page 52, guys. Shh. Let's look at page 52. Okay? Where it says domain and range of a relation and function. You and your partners go do this. So I'm giving you the following function. Now, function is just a special relation, meaning it's one input is has one output. Okay? So when they say function, just a special relation. All right? Special relationship. I'm telling you that the domain is 1, 2, 4, 7, and the range is 2, 3, 8, 5. So discuss with your partner what you believe is the definition of domain and range. So do that right now. With your partner, discuss what you think is the domain and range of that function. You have to discuss it with your partner.
What's the answer?
Discuss with your partner. Discuss with your partner. Look at the example that they give you. They give you the function, they tell you the domain, they tell you the range. So, what do you think domain and range is?
Oh, look, but that can't be the right. I'm still clueless about this. You mean talking about these arrows, right?
Look. So, this is the graph, right here. Yeah. That's a vertical line. That's a graph. That's the graph, okay? So can I draw a vertical line anywhere on this graph and hit it more than once? Yeah, if I draw that line, that vertical line, I hit it all the time.
That's my
Here's
answer.
a horizontal.
That's right. It's got to be right.
I'm going to draw a vertical line and only hit each vertical line is only going to hit one time.
So this one only has one letter.
Right.
Okay.
Right.
That's why.
I think I clueless at first. Like, they said, oh, the vertical line.
All right, y'all come up with an answer. All right, Drake.
Domain is the same thing as all the X's, and the range is all the Y's.
Okay, listen. Shh. I like what he said. Say it again, Drake, for those that weren't listening.
All the domains are the X's are the first letters of each one, and the Y and the range is the Y.
Okay, now my only problem with that, and that your answer is completely right, is what if I had W and X's?
Well, it'd be W. Oh,
Okay.
The first one of each.
Okay, what's a better term for X? Input and output. Good. So domain is your input. That's the definition of domain. The range is the output. Domain, input, range, output. All right. So let's, as a class, do A, and then I'll let you and your partner together do B and C. Okay? I know. So horrible. Huh? All right. Shh. Okay, so for A, what is my domain? 1, 2, 3. So you're going to just, for A, you could put D equals 1, 2, 3. For the range, what's your range? 5, 6, 5. Now, notice how you have 2 5s? You can only write 1 5. So my range, I'm just going to put 5 and 6. Okay?
Even when it's more than like 2, you could still just represent.
Yes. Even if I had all zeros, I would just represent it once. Okay? So you and your partner. Now, let me talk about C for a second.
I'll finish.
Y'all need to stop. For C, okay? C is not a table anymore. It's a graph. So I have to make sure that I include every point possible that I could draw. Now, when it's a graph and it's made up of line segments, there's a bunch of points on each of those line segments. So think about how you can represent all those points. If you were to pick a point on any line, Christian, don't do that. Okay? So right now, you and your partner, think about the domain and range for B and C. Y'all talk, y'all discuss. What do you think the domain and range are? Yes. That line, I'm not sure what that line is about, but it does not matter. That's not going to make a difference for domain and range. Talk with your partner. Huh? No, not for domain and range. I like all this critical thinking y'all doing.
I don't like it. It's too bad I'm done.
Really? What'd you get for C?
He didn't do 6. He did 0, 30, 60, 90, 120.
Well, what about...
Alright, so wait, look, 0 through 1. So wait.
Yo, you can do your own question.
Yeah, but wait.
You want me to answer it? You can think about it.
No, I'm gonna tell you, you're saying this right. Do I put 0 dash?
Yeah, you can do that. You could have answered your own question, Christian. Yes. I want to represent all the points possible.
Who's the smartest boy in this class? I said the smartest boy. That's the smartest. Oh.
Alright. I know y'all got B, right? Because B was exactly like A, right? So what's my domain for B?
0 through 150.
B.
I'm not even paying attention.
Okay, so the domain for B, -2, 2, 4, 5, and 6. Alright, what's the range? Okay. Now for C, okay, how many of y'all said the domain is 0, 30, 60, 90, 120, 150, and 160? Okay? Okay, and I totally understand why you said that, because those are my X values. Those are my X scales, right? So for the Y's, you put 0, 1, 2, 3, 4, 5, 6, 7. Correct?
Yes.
Okay. Now, what if I said, listen, what if I said, well, that's all good and all, but you didn't include this point in your domain, did you? Right? There you go. The domain is 0 through 150. All the numbers between 0 and 150. The range is what? 0 to 7. Okay? 0 to 7. So all my points have an X value somewhere between 0 and 150. Do y'all all see that?
Yeah.
And then all my Y values have a range between 0 and 7. Do y'all see that? I need to count for the entire graph, not just those numbers. All right, we still have 5 minutes, and we still have the back of the page. Okay?
Is somebody gonna put up the clickers right now?
Guys, you're still going to have homework, even if I don't finish the back of the page. All right, now, function notation. Remember, a function is just a special relation, and this, the way you see this, where I just wrote on my tablet, what I just boxed in, that's just a special way of saying something is a function. Now, we read that as saying f of x. And when you get into college, they do everything. You talk about functions until you're blue in the face. Okay? So, I would read this f of x. How would you read this? How would you read? Okay, so we know how to read it, right? Now, I can use whatever two letters I want, but this, listen, this always symbolizes a function. Okay? Now, so if I had this, f of x equals 2x plus 3, which is what's on your paper. Okay? Now, remember, a function has an input. It has one input for every what? Output. So one input has one output. Well, I see my input is x. Well, we know our input is x, but I don't see an output. What's my output? No. Almost. F of x. That's your actual output. That's just a fancy way of y, right? And to say that it's a function, they do f of x, meaning it's a function based on x. Okay? So if I wanted to know this, you're right, it is a linear equation, but if I wanted to know this, okay, what is it, hold on, what am I asking for? I'm asking for the output when what?
What does that equal?
Not when f. When my, what is negative 2? No. When my input is negative 2, I want to know the output. All of this is the output. Okay? That negative 2 is just telling me what I'm inputting. Okay? So, everywhere I see x is, everywhere I see it's x, I put in negative 2. Okay? So, what is my output when my input is a negative 2? How'd you get that? Negative 4 plus 3 is? Okay, so I have this. Okay? Now, notice we don't do anything to the left side. It's just like if it was y. Okay? So, my input is negative 2. My output is what? Negative 1. Okay? Suppose I had this. All of it. This is the output, so the output equals negative 1. Okay? Let's do some more. Okay? If I have g of negative 7 equals 0, what have I done? Oh, no, I'm sorry. What did I figure out? My input was what? And when I inputted negative 7, I got out 0. Y'all understanding this? Okay, just like if I input a gorilla, I get out a banana. Same thing. I input a negative 7, I output a 0. Okay? So if I wanted to find, listen, if I wanted to find f of negative 1, what would I do?
F times negative 1.
There you go. Plug in negative 1 every time I see an x. Which is a positive 1. Okay? Yeah. That's from the original function. Yes. Oh, yes. All right. We didn't have time to do the clickers, so just pass the clickers forward. Your homework's on the board.